Okay, students, welcome once again to the session. So we were doing matrices and we have seen how the matrices are added. Then we have also seen how a matrix or a number is being multiplied with the matrix, and these two operations are known as addition of matrices, and second is known as scalar multiplication of matrices. Scalar multiplication of matrices simply means you are multiplying a matrix by any number, right? And when you are multiplying a matrix by any number, it simply means you must multiply all the elements of that matrix by that number, right? Clear? Now let us take an example in the same direction. If A is equals to matrix this 1 2 4 3 0 5, B is equals to 2 4 1 0 3 2. Find 3A plus B. See, you have to find out 3A plus B. Try to understand the concept. 3A plus 2B. What is given? A is given and B is given, right? So what is 3A? 3A means scalar multiplication of the matrix A with 3. So 3A means 3A. How you will calculate 3A? See, what is A? A is this, multiply all the elements of A with 3. So what you will get? That is 3, 6, 4. 3 1 the 3, 3 2 the 6, 3 4 the 12, right? This is the first row. Second row is what? 3 3 the 9, 3 0 the 0, 5 3 the 15. This is 3A, right? 3A, simply multiply all the elements of the matrix A with 3, you will get 3A. Likewise, you can find out 2B. 2B means multiply the matrix B, all the elements of the matrix B by 2. See, B is this is A. So 2 into 2 is 4, 4 into 2 is 8, 2 into 1 is 2, right? 0 into 2 is 0, 3 into 2 is 6, 2 into 2 is 4. So this is your 3A and this is your 2B. What is next? You want to calculate 3A plus 2B, means you are adding these two matrices. 3A is matrix 1, 2B is matrix 2. You can add up these two matrices only if you know the condition, if they are of the same order. So the order of this is 2 by 3 and the order of this is also 2 by 3. Both are the matrices of the same order. Therefore, they can be added, right? We can add them. So 3A plus 2B, 3 plus 4, that is, should I write 7, 6 plus 8, that is 14, 12 plus 2, that is 40, right? And then 9 plus 0, that is 9, 0 plus 6, that is 6, 15 plus 4, that is 9. So 3A plus 2B is, see, this matrix 7, 14, 14, 9, 6 and 19, right? So simply whenever you are using a scalar multiplication, simply means we are multiplying a matrix by any number, and multiplication of a matrix by any number simply means multiply all the entries or all the elements of that matrix with the same number, right? Take an example 6. Find the matrix A. If 2A plus B, see, 2A plus B is given like this and B is given like this, you have to find out the matrix A. This is a very simple equation. Actually, you have solved the equations in number system. 2x plus 5 is equals to 9. What we did? 2x is equals to 9 minus 5. So 2x is equals to 9 minus 5 is 4. X is equals to 2. So x is a variable. Here matrices behave like a variable. This is actually known as a matrix equation. 2A plus B is equals to the matrix this. We call it as a matrix equation. B is given, find out the value of A. So very simple. What you have given? We have given 2A plus B is equals to the matrix 6 minus 2 and 4, 2 minus 1 and 1, right? You want to calculate A. B is given. From here, 2 times of A is equals to what? 6, 2, minus 2, minus 1, 4 and 1, minus this b will transfer from left to right, and what is b? B is this 2, 3, minus 2, 7, 12 and 8, right? Subtract, and you know two matrices can be subtracted only if they are of the same order. Check the condition before using the operation. The order of this and this matrices are same. So what is the value of 2a? 2a will come out to be 6 minus 2, that is 4, minus 2 and minus minus plus, that is 0, 4 minus 12, that is minus 8, right? Row 1. 2 minus 3, that is 2 minus 3, that is minus 1, minus 1 minus 7, that is minus 8, right? And 1 minus 8, that is minus 7, right? So if 2a is this, then what is a? So naturally a is equals to 1 upon 2 of 4 minus 1, 0, minus 8, minus 8, minus 7. So what does it mean? We have to multiply this matrix by 1 upon 2. So finally a is equals to what? 4 upon 2 is 2. This is 0. This is minus 4. This is minus 1 upon 2. This is 2 for the 8 minus 4. This is minus 7 by 2, right? So as we obtain the matrix here as the same one, right? So by having these two examples, I hope you understand how the concept of addition and scalar multiplication runs very much parallel to each other. In these two questions, we have used both the operations, addition, subtraction and scalar multiplication. All the three operations we have already used in these two examples, right? Let us have another example. The following matrix represents the result of BCom class. So this is a matrix which shows the result of the students of BCom class, right? What this matrix represent? Let us see. The rows represent the three sections of the class, right? Rows, row 1, there are 3 rows. Row 1 is section 1, row 2 is section 2, row 3 is section 3, okay? Let me specify here. This row 1, this is section 1. Row 2 is section 2 and row 3 is section 3, right? It is given. The first 3 columns means this column, and this column. They are the first 3 columns. The first 3 columns represent the number of students securing first, second and third divisions respectively. They are the students who secure first division, they are the students who secure second, they are the students who secure third division. And the fourth column represents the number of students who failed. Oh, the column 4 represents the failed student, right? Failed. In the examination, what you have to do? Number 1, how many students passed in 3 sections respectively? Now understand the matrix first. This is a matrix having 3 rows and 4 columns, right? Its order is 3 by 4. So it contains 3 rows and 4 columns. The first row simply represents the section 1, second row represents the section 2, and third row represents the section 3. So section 1 means there are 1 student in section 1. Now look at the column. Column represents the first 3 columns. The first column represents those students who secure first division. Second column represents those students who secure second division. Third column represents those students who secure third division. and fourth column represents those students who failed. Clear? Are you getting the data? How the matrix is being represented here? So how you understand it? See at row 1. Row 1 is what? Row 1 contains this 1, 2, 3, 4. Okay, this is your row 1. Let me explain. This is your section 1, right? Right? This is section 1. I am showing you by one row only. The rest you can understand. This is first division, this is column 2 second division, this is third division, and they are failed, right? So what section row 1 represents? Row 1 means in section 1 there is only one student who secured first division, there are 2 students who secured second division, there are 3 students who secured third division, and there are 4 students who failed. Clear? Understand? In row 1, what row 1 represents? Row 1 represents the section of students of section 1, right? Students of section 1 means there is only one student in section 1 who secure first division, because we are having here 1. There are only 2 students in section 1 who secured second division. There are 3 students in section 1 who secured third division, and there are 4 students in section 1 who failed. Likewise here, there are 5 students in section 2 who secured first division. There are 6 students in section 2 who secured second division, and there are 7 students in section 2 who secured third division, and there are 8 students in section 2 who failed. Likewise, there are 9 students in section C who secured first division. There are 10 students in section C who secured second division, and there are 11 students in section 3 who secured third division, and there are 12 students in section C who failed, right? Now, what you want to calculate, how many students passed in 3 sections. So, how you will determine how many students passed in 3 sections? So, look at this. In section 1, the number of students who passed: 1 first division, 2 second division, 3 third division. 3 plus 2 plus 1, that is 6, because 4 they are failed. Likewise, in section 2, 5 plus 6 plus 7, 7 plus 5, 12, and 6, that is 18. In third, 11, 9, 10, and 11. 11 plus 9 is 20, 20 plus 10, that is 30. So, this is the data. The number of students who passed in 3 sections, there are 6 students who passed in section 1. There are 18 students who passed in section 2. There are 30 students who passed in section 3, right? So, the number of students who passed in 3 sections are 6, 18, and 30. So, we are done part 1. Part 2, how many students failed in 3 sections? So, it is very clear from the data. The fourth column represents the number of students who failed, right? So, there are 4 students who failed in section 1. There are 8 students who failed in section 2. There are 12 students who failed in section 3. So, naturally, the answer of part 2 is 4, 8, and 12. It is very clearly mentioned in column 4. Part 3rd is what? Write down the matrix in which number of successful students is shown. So, number of successful student means delete the number of students who failed. So, the 4th column, if we delete from the matrix, so the remaining matrix will represent the number of students who successfully passed, whether they are getting first, second, or third. So, see the first 3 columns, 1, 5, 9, 2, 6, 10, 3, 7, 11 will represent a matrix of number of successful students, right? Let us take the more example of the same nature. Let P is equals to this matrix where rows represent the number of items of type 1, 2, 3. It's very much similar. Look at here, as we did in the last case, this is also matrix having 3 rows and 4 columns. Row 1 item of the type 1, right? Row 2 item of the type 2 and row 3 item of the type 3. There are 3 types of items respectively. And columns represents the 4 shops. A, this is B, this is C, and this is D, right? There are 4 shops A, B, C, D represented by the columns, and there are 3 category of the items available on these shops 1, 2, 3. Clear? So this matrix simply represents what? 3 variety of the items or commodities are available on these 4 shops A, B, C, D. This is what this matrix in fact represent. What is next? Let Q is equals to this. They have taken a matrix Q like this, and R is another matrix like this, where elements in Q represents the number of items, number of different items delivered at the beginning of a week, and the matrix R represents the sales during that week. Now after this matrix P, they have taken a matrix Q which is also of the same order. The matrix Q represents the number of items, different items delivered at the beginning of the week, and R represents the total sale during that week. Clear? So R is the sale matrix, Q is the number of items, different items delivered in the beginning of the week, and P is the matrix. It contains 3 variety of the items available at the 4 shops A, B, C and D. Now what you want to calculate? Find the number of items delivered at the beginning of the week. Oh, number of items delivered at the beginning of the week. So Q is what? Q simply represents number of items of different type delivered at the beginning of the week. So Q is known as delivery matrix in the beginning of the week, right? So how we will get the number of items delivered at the beginning of the week? If we add P and Q, sum of P and Q will represent the number of items delivered at the beginning of the week, because Q simply represents the number of different items delivered at the beginning of the week, and P represents the 3 categories of the items available at the 4 different shops A, B and C. So if we add up P and Q, we will get the total number of items delivered at the beginning of the week. What we need to calculate in case 2, the number of items at the end of the week. So at the end of the week is what? What is R? R represents the sales during that week, right? Q is at the beginning and R is the sales during that week. So R is a sale matrix. R is a sale matrix which is being considered during that week. But what you want to calculate? The number of items at the end of the week. So if we sum of P plus Q represents the number of items delivered at the beginning of the week. If we subtract R from P plus Q, then it will represent the number of items at the end of the week, because P plus Q is the delivery of the items in the beginning of the week, and R is what? R simply represents the sale during that week. What we want to calculate? The number of items at the end of the week. R doesn't contain at the end of the week, so therefore P plus Q, the delivery of the items at the beginning of the week minus sale at the end of the week, will give you the number of items at the end of the week, right? So P plus Q minus R will represent the number of items at the end of the week, right? Let us take this case. This is also a very good question. Actually, this is a same question as we did in case of number system. What happens in number system, we solve two equations for x and y. A number of methods are available to find out the solution of system of two linear equations in two variables. The same situation is here. In general perspective or in general number system, we call them an equation, but here we call them as matrix equation. So see what is given here. Determine the matrices A and B such that A plus B is equals to this and 2A minus B is equals to this, right? So A plus 2B is equals to this. This is called a matrix equation. 2A minus B is equals to this. This is also called a matrix equation. So you have given two matrix equations, and from these two matrix equations you have to find out the value of the matrices A and B. So it's a very similar case as we did in case of general equations solution. And in general equation solutions, a number of methods are available. And one of the most important method is what we generally equate one variable first, then it should cancels out, we get the value of the other variable, and then we put the value of the obtained variable in the any one of the equations to find out the value of the other variable. So same we will use here. See what we have given. A plus 2B is this matrix equation. 2A minus B is the second matrix equation. Take this as 1 and this as 2, right? Now look at this carefully. What we should do, either we should equate A in both equations or we should equate B in both equations. It's up to us. It's not any issue. Here A plus 2B, but here we are having 2A minus B. So look at here, 2A minus B is equals to this matrix, right? 2, 2, 2, 0, minus 1, minus 1, 1, 5, 6 and 2. This is our 2A minus B. Equation 1 is what? A plus 2B. So see, if we multiply this equation by 2, what will happen? See, multiply this equation by 2. And so we will multiply this matrix by 2 also. See, this is 4A minus 2B, and what you will get here, multiply this matrix by 2, that is 4, 4, 0, minus 2, minus 2, 2, 5 to the 10, this is 12 and this is 4, right? After multiplying this, we get 4A minus 2B is this, take this as equation number 3. So we get this equation number 3 as 4A minus 2B is equals to 440, 440, minus 2, minus 2, 2, 10, 12, 4, 10, 12, 4, right? We are getting this equation here. Now what we will do, this is 4A plus 2B equation number 3, right? And equation number 1 is what? Equation number 1 is A plus 2B. Add up 1 and 3, right? Adding 1 and 3. What we will get? See, 1 is A plus 2B plus 3 is what? 4A minus 2B. This is equals to what? This matrix means 1, 6, minus 5, 2 minus 3 and 3, 2 minus 3 and 3, 0, 3 and 1, 0, 3 and 1, right? This is what? This is A plus 2B, and 4A minus 2B is this, plus add this matrix here. This is what? 440, 4, 4, 0, minus 2, minus 2 and 2, 10, 12, 10, 12, and 4, right? We are getting this. So 2b and 2b will be cancelled out. What is left? 4a plus a is equals to 5a. 5a is equals to multiply these two matrices. What you will get? 1 plus 4 is 5. 2 minus 2 is 0. 0 plus 10 is 10, right? See this. 6 plus 4 is 10. Minus 3 minus 2 is minus 5, right? 3 plus 12, this is 15. Minus 5 minus 0 is minus 5. 3 plus 2 is 5. 1 plus 4 is 5, right? So 5a is equals to this. So what is the value of a? A is simply, this implies a is what right here? A is, divide the whole matrix means 1 upon 5 with this matrix, right? Same. 5, 10, minus 5, 0, minus 5, 5, 10, 15 and 5. So simply the value of a will come out to be, divide all these numbers by 5. What you will get? 1, 2, 1, 2, minus 1, right? 0, minus 1 and 1. 2, 5, 3 the 15 and 1. This is the value of a. What is a? See here. This is a. 1, 2, minus 1, 0, minus 1, 1, 2, 3, 1. So once we have obtained the value of a, how we can find out the value of b? If a is there, from equation 1, put, see, what is equation number 1? See, a plus 2b, a plus twice b is equals to 1, 6, 5, 2, minus 3, 3, 0, 3, 1. This is equation number 1. A we have already obtained. So what is the value of 2b from here? So 2b is equals to what? 1, 6, 5, 2, minus 3, 3, 0, 3, 1. Right? Transfer this a from left to right. Right? Minus a means, what is a? A we have obtained 1, 2, minus 1, 0, minus 1 and 1, 2, 3 and 1. Right? What is the value of 2b? 2b is equals to what matrix? 1 minus 1, that is 0. 6 minus 2, that is 4. Right? 5 minus 1, that is 4. Right? 0, 4 minus 4, right? What is the a? 1, 2 minus 1, 1 minus 1, 2, 3, 1. Oh, sorry, this is 2. A is 2, 3, 1. So what is coming out? 0, 4 minus 4, right? And then 2 minus 2, 2. 2 minus 2 and 2. 2, 0, 0. This is the value of b. So this implies, what is b? B will be equals to, divide it by 2. 0, 2 minus 2, 0, 2 minus 2, right? And then 1 minus 1, 1 minus 1 and 1, 1, 0, 0, right? So this is your matrix B and this is your matrix A. So this is how we can find out the matrices A and B by solving the matrix equation in a similar way as we solve the general equations to find out the values of the variables x and y. So students, I think I should stop it here.